Eugene here. We're going to talk about the TF Luna, which is a LiDAR. So LiDAR, the first Li meaning light, DAR meaning short for radar. So LiDAR is light radar. And the way that this works is we have a Luna and it emits out light. The light then reaches an object, reflects back, and then goes back to the detector. Once it hits the detector, that's called the time of flight. So that's how it measures what the actual distance is between the Luna sensor and the object or the wall or whatever it is that you're going to measure. So here we're going to have a picture of what it actually looks like when the LiDAR is connected up to the Raspberry Pi, and there's also a picture that shows a nice breadboard clean layout, so that way you can physically see the difference between the two. So we'll dig into what the two programs look like that actually operate the LiDAR.
Here we have the Raspberry Pi 4 and its latest operating system, which is Trixie. And it's a Debian version, and I'm going to show you the difference between the two Xojo and CPP versions. So here we're just going to execute this one, and you can see what that layout looks like. And then here we're going to do the C++ one that's running WX widgets. Oh, I'm compiling it. Give it a second, it'll finish compiling. It's actually pretty quick. And then once that's done, we'll run it. And there we go. So the two buttons are aligned in the same position. I'm trying to keep all of the information the same, so when you're inputting information, they're the same. So that's pretty good. It just makes it a lot easier just to make it so that you can have a good, reasonable comparison of the two. So on here, when you click the distance button, it actually measures the distance between the sensor and whatever it's going to be reflecting from. So if I were to try and aim this sensor through my door into the other room, I should get a much larger number, right? So now I'm about 21 feet, which is about right. When I click on the temperature value, the temperature is the temperature of the internal chip in the TF unit. So let's say right now the temperature here in my room is about 18 degrees Celsius, which is about 64 degrees Fahrenheit. So it's definitely not warm. And when you click on the temperature, it says that it's 36 degrees Celsius. It's not even remotely close to that. But that's what the temperature of the internal chip is. The amplitude is a measurement of the signal strength. So if it's below 100, you probably shouldn't be relying on that number, or if it's close to 65,535, you shouldn't rely on that either. So right now we're at 8,879, meaning we sent a signal and it came back at a reasonably good number, which is good. If it gets close to 65,535, that means that you almost have a reflection like you've aimed it at a mirror and it's getting erroneous data because you probably have interference going on there. So it doesn't really have a good reliable distance measurement to it. The other one is the rate. So here, the rate here is now set up as 100 Hertz, meaning it can measure up to 100 measurements per second. We don't need that because we're just pushing the buttons right now, but you can go up to that high of a number. The firmware is 3.5.1 as of January 31st, 2026. The TIX is an internal clock that's inside the TF Luna unit. So about 1,000 ticks is about 1 second. It's not actually meant to measure seconds, but it's used as a measurement device to clock the number of ticks that's actually going on. So when you want to get the rate and figure out how many measurements you can take, that's what the ticks value works on. If there is any error code, it'll show up here. Right now the error code is 0, and 0 means no error. Operation mode. So right now it's in a continuous operation mode. A trigger would be, let's say it's available to take another measurement. It will, so you can get up to like the 100 measurements per second if you use the trigger. The power mode is either normal, so it's always going to continuously use a little bit of electricity, whereas you can put it in a power saving mode where you kind of have to wake it back up, take your measurement, and then you can put it back down for definitely for saving uh, battery usage. So if you were to have a battery, you want to maximize the length of the life of the battery before you have to recharge it again or replace the batteries. This is what you'd use. Then there's the status. Is it enabled or is it disabled? So when you actually click on the button to get a distance, and I can't click it fast enough, the when it's actually doing the distance measurement, that's when it's enabled. And right now it's not taking a distance measurement, so it's disabled. The next one is the amp threshold. So if you have before when we were talking about it, if you were to have a value that's above 100 but less than 65,535, here what we're doing is we're setting the threshold value. So if it's below that number, we want to give it a number, meaning it'll output. So if it's below 100, it's going to go to the default zero value of 0 centimeters. So that's what the threshold value is. Dummy distance. So this is the distance based on the amp threshold. So you can change this. So let's say it's below 100. You could set it to, let's say, 1 centimeter or 2 centimeter. I just have it to the default of 0. And the minimum distance. So the minimum distance that you can try and read from is 0 centimeters. If you have, let's say, it on a robot, and the distance between the center and the sensor and the front of the robot is, let's say, 5 centimeters, you want to make it so that you put that number to 5 centimeters, so that way it realizes that that's where the front of the robot is. And the maximum distance. So the default values with the TF Luna are 9,000 centimeters. Right now, usually it's 800 centimeters or 26.2 feet. It can go up to 9,000 centimeters. At least that's what the settings say, which is a lot. I think that's what, over 262 feet. I think that would have to be clear. It would have to be no fog or no smoke or anything like that. I haven't tried it that far, but that's what it's supposed to be. And then on here, you can set different measurements. So right now, if you, the default address with the I2C is 10, and that's in hexadecimal. And on here, the way to check that out is if you click I2C detect /Y1, and it shows you here that it's actually, the signal is 10. And of course, if you want to reset the sensor back to its factory defaults, you click on this. Now it's performed a soft reset back to the default values within the TF Luna unit. So that's about it. And it's a really good program to try and show all of the different types of things that it can do. All of the code is available. If you, an example here, if you open it up, there's two different files. One's the header file that contains the code that's specific for the TF Luna. The other one is the CPP file, which is the generic code that's used for WX widgets to like create a button and everything else. And similarly with the Xojo file, everything is in one file for Xojo, and it'll show the code, it'll show the graphics of the GUI itself. So thanks for viewing, and if you have any questions, by all means put something in the comments below. Thanks. Bye now.